Hello and welcome to today's class. We'll look at yet another past question under the study of hydrogeology. Right? This question says a well is located in an aquifer with a conductivity of 50 meter per day and a storage of 0.005. The aquifer is 20 meter thick and it pumped at a rate of 2725 meter cube per day. What is the drain at the distance of 7 meter from the well after 1 day of pumping? So let's get this question done, please. All right, first things first, we said your first task in science is to list out the givens. So first things first, what are we given from the question? Solution. So given. All right, first things first, the question says a well is located at an aquifer with a conductivity of 50 meter. By the way, note that there's what we called hydraulic conductivity, and hydraulic conductivity is abbreviated as what? As K. So I have K as being my hydraulic conductivity is K, please. So that becomes what? 50 meter. I have the value as what? 50 meter per day. I have this. Next up, question says, please watch the way I'm breaking out parameters. So I said that a well is located in an aquifer with a conductivity. We said conductivity represents what? K, right? It's not basically conductivity, it's said to be hydraulic conductivity in full sense. So I have this. All right, per day, and the storativity. We say storativity. Check our last video on when we calculated storage coefficient. It was x. So I'm given the value for storativity, that's x. So I'm given x as being equal to 0.005. Last class we said we established that storativity, perhaps either I call it storativity or you call it storage coefficient, it has no SI unit. We say storage coefficient x is equal to what? Q all over A into the H over the N. This was last class example. Sorry, past ones are treated, right? I said it has no SI unit. So in this case, it was called storage coefficient. Here now it was called what? Storativity. They are still both the same thing, please. So that's x has been equal to 0.005. I have this. The corner says the aquifer is 20 meter. Please, the aquifer is what? 20 meter thick. Now listen up. Go back to your concept. Just note that transmittivity is equal to what? KB. Note that transmittivity is equal to K. Here is called what? There is called hydraulic conductivity. So times what? What's this B? B is called thickness. So notice this concept. So I'm given thickness B as being equal to what there? 20 meters. Please note that transmittivity is equal to conductivity times what? What is please? Thickness, please. All right, next up. So the aquifer is 20 meter thick. So that's B. Thickness is for B, and is pumped at a rate of 2725 meter rate. Last class we emphasized on this Q, this charge rate. So I made the word that's Q. Anything rate of that's Q, please. Q is what there? 2725 meter cube per day, please. All right, per day, that's for value for Q there. Question says per day, what is the drain at the distance? So the task behind drain is simply H2 minus H1. H2 minus H1. That's the expression for drain, please. Is unknown. A distance of drain. Okay, what is the drain at distance of 7 meter? distance. This is S is not distance, S is storage, please. And B is thickness. K is conductivity. Q is what? Rate, right? H2 and H1 is called drone drain, right? I'm given distance here. So distance here is R in this case. R is distance has been equal to what? 7 meter. Look at the way I pick out my parameters. So note how this works, please. All right, what says what is the drone drain, right? Which is H2 and H1. So at this point now, I'll recall that H2 minus H1 is equal to Q all over 4 pi T 4 pi T W U. So this is my mathematical expression for calculating H2 minus H1, which is said to be the drone drain, right? All right, let's get this done, please. So first, to get the drone drain, which is H2 minus H1, are we given Q? Of course, Q is given, no problem. Are we given 4 constant value? Pi is constant. T, what's T? T is not given here. But mind you, I just wrote out something now. So look at this. So at this point now, I'll try to get T, I'll try to get U, right? And perhaps the value of W, so I can get H2 minus H1. So at this point now, let's get T, please. Calculating for transmittivity, which is T, capital T. So recall that transmittivity, capital T, is equal to the product of what? The conductivity times what? Thickness of the aquifer. Now T now is equal to, what's your K? That's what, 15 meter per day. 15 meter per day, right? Multiplied by, per se, let me write it this way, per day, multiplied by the thickness is in what? Thickness is B. That's what? 20 meters. From here now, my transmittivity is equal to 15 times 20. 15 times 20 there. I have 300. By the way, meter times meter is what? Meter square per what? Per day. So transmittivity is equal to 300 meters square per day. So I have this one as my value for this man here. Let's get U. Let's get U. Let's get U, please. From here now, what's U? At this point, let's get U. But also, let's get U. U is equal to U is equal to R square X all over 4TT. This way, please. So please record this formula, please. Just master them and you're off, please. Just master them and you are off. Right? All right. From here now, let's get the value of U, please. From here now, U is now equal to, what's your R? That distance, 7 meter. That's 7 meter all squared times, what's your S? S is storage coefficient. That's 0.005. 0.005 all over 4 multiplied by T is transmittivity. That's the value of what? 300. I have 300 meter square per day times T. Small t represents what? Time, right? Time. And that time is what? 1 day. Because we're told to find the find the drone drain, right? After a day. I think it's after a day. The question there. So it was after 1 day of pumping. Yes. after 1 day of pumping. So time there is what? Just 1 day. So 1 day. I have this. So let's get this done, please. So U is equal to, by the way, you must be asking, what is U? What is U? U is called the initial velocity flow, please. The initial velocity flow. That's U, please. All right, from here now, 7 squared is of course 49 meter, 49 meter square, right? By the way, 7 meters times 7 meter, that's 7 times 7 is 49, meter times meter is meter squared. So I have 49 meter squared times 0.005 all over, listen up please, this day we cancel this day, yeah? So I'll have 4 times 300 times 1, that becomes 4 times 300 meter squared times 1. So I have this. At this point now, what next? U will be equal to, multiply through, what do you get? Multiply through 49 multiplied by 0.005. I have 0.245 all over, so the meter squared, all over 4 times 300, 4 times 300 times 1. I have 1200 per se. I have meter squared here. Meter squared. What do you observe here? What do you observe here? By the way, all right, okay, I have this. What do you observe here? This will cancel this, right? So U now, U will be equal in value to, divide is to, what do I get? 0.245 divided by this one. I have 2.041 times 10 to power, perhaps 01, make it 4 digits, 6 times 10 to power minus 4. I have this. Please, of course, the essence has cancelled out. Of course, it has cancelled out, right? Observe that 7 meter square is 7 meters times 7 meter. 7 times 7 is 49. Meter times meter is meter squared. So I have this. Of course, follow my pattern here. I have no assignment for this one. Now, let's get this done, please. What's now W? Here's the tax. Here's the tax. I will do a video on how I will explain how to use WU. See, after getting this value of U, there is a perhaps I'll show that stuff on the screen. There's a photocopy that I'll show you on the screen right now that contain how you use U, right? So the text that check for U, right? Or perhaps check for W. So go for 2, right? So that it has a what? An index of what? -4. The value we're having there, it will have a value, right? Let me check my PDF here. So WU here is 7.94, right? So try to check the screen. I'll drop the stuff in the screen, right? So WU. So the test that this is your U 2 point. Go for 2, right? So that 2 have an index of -4. The value you'll be seeing there is what? 7.94. So my value for WU now, WU is what? This value. So let's get this done, please. From here now, the value for H2 minus H1 will be equal to Q. What's your Q there? Q is 2725. 2725. By the way, meter cube per day. Meter cube per day all over, I have 4 times 22/7 as the value for pi, multiplied by T. Transmittivity is of course 300 meters square per day. 300 meters square per day. What next? Times WU. What's WU, please? That's 7.94. So let's get this done, please. Let's get this done, please. By the way, observe, please. Just setting myself. If this one here cancel this one here, observe. Meter square per day, cancel out meter cube per day. I'll be left with just meter, so I'll be having meter left. So my SI should be in meter. Height, right? Drone drain height meters, so it's correct in meters. So let's get this done, please. From there now, what do I get? Check up there. I have h2 minus h1 has been equal to multiply numerator. If I multiply numerator, that's 2725 times 7.94. I have 21636.5 all over. Check them up, please. Multiply that 4 by pi by 300 there. 4 times 3.142 per se, or perhaps use 20/7 if you want to, times 300. I have about 37704. Divide numerator by this one here is in meters, please. Divide numerator by denominator. I'll have that h2 minus h1, which is the what? The distant drain. Or what they used, what the language they used. The language was the drone drain, right? Let me check. What is the drone drain? Yeah. So the drone drain, which is h2 minus h1, is equal to divide your numerator by denominator 636.5 divided by denominator. I have 5.738. By the way, please, what's my unit in meters? In meters. So this becomes your answer to this particular question. So see you in the next class.